What up, what up? Hey guys, how you guys doing? Welcome back, Happy New Year to everyone watching this for the first time. I am yours truly, the Math Professor, and I know it's been a minute since we last talked. A lot has gone down in the past few months with us being in quarantine and having to lock things down. And so in the midst of all that, I didn't think it would be wise to just keep these videos coming. So I wanted to get back to you guys after everything settled. I know some of y'all are a little sad, but hey, listen, we back on it. Okay, that being said, my goal again is to help make this thing we call algebra a bit more simpler for you moving forward. Either way, ready or not, it's about to go down. What up, what up? Welcome to my house. I am your teacher and facilitator, the Math Professor. And guys, it is so good to be back again doing these videos, hopefully giving you a little bit more knowledge to help you overcome this thing that we call algebra. I hope everybody is doing well and that you fared well with the entire pandemic situation. And I'm hoping that you're staying safe and socially distancing like you're supposed to, even though I know some of y'all really didn't do well to begin with. But okay, that's a whole nother situation. Welcome back. Today we're going to be focusing on something that we call proportions. Now, proportions is tied to an actual bigger picture. And one of the things that I'm going to do that I haven't been doing in my previous videos is listing what standard the skill or lesson is tied to. And there's a reason why I have to do that, because I want you all to be able to walk away from these videos understanding what it is you're going to learn and what it is you have to learn to consider having mastered the standard, okay? And so I'm in the state of Florida. We have what's called Common Core standards, and so that's what I'm gonna list, okay? Our standard that we're gonna be focused on today is MAFS 912 REI 2.3. I know, sounds crazy. Sounds like something out of a alien horror movie. It sounds like something that the CIA is gonna list when they're talking about some crazy person. But hey, it's a standard. Okay, I'm gonna say it again, and then I'm gonna break down what the standard means. Okay, again, the standard is MAFS 912 REI 2.3. Now, what does all of that mean? It comes down to three things, and that's what I'm gonna break down. The first thing that the standard says you gotta be able to do is you gotta be able to solve linear equations. We're gonna jump more into that. I've already dished out a couple of videos pertaining to linear equations, but I'm gonna dive a little deeper into it with some more videos. So trust me, more is coming. But if you haven't already done so, check some of the videos out. Like, for real, they're good, they're real good. All right, the second thing you gotta be able to do is solve linear inequalities, okay? And so I haven't done much on inequalities. I'm actually getting ready to bring a depth or a full roster of videos that are gonna tie us to linear inequalities. So, okay, that's coming too, okay? TBA on that, okay? And then the last thing you gotta be able to do is solve inequalities or equations that have values represented as variables. Okay, and that's where proportions kind of kick in, the skill where we learn about proportions. Now, in order for us to do a really good job on proportions, we got to understand what it is, right? Think about portions, right? Every time I hear the word portions, it's tied to like a diet. Nobody likes those, okay? That's when somebody tells you, probably a doctor tells you how much you can or can't eat, or how much you should be eating if you're trying to drop down a couple of pounds, or how much more you should be eating if you're trying to gain more weight. Okay, either way, portion simply means that you're only able to eat a set amount, or it refers to a specific amount or a part of a whole. Okay, you got the whole thing, but we're only going to be focused on a part. Okay, and so when we start talking about proportions is when we take two different parts and we compare them to one another. All right, we take two different parts and we compare them to one another. And I'm going to drop the word of the day while I'm here. The key to this whole thing, though, is they have to be corresponding. Again, they got to be corresponding. What does corresponding mean? Corresponding means that we may have two different parts or two different objects, but what we're going to be focused on is located in the same space of the two different objects, right? Clearly, I know that's not going to be enough for you, so I'm going to drop some examples and hopefully it makes a little more sense, okay? So in this example, we're going to talk about two cars, right? You got two cars. Now, it doesn't matter if the cars are exact. Both cars have trunks. The car to the left has a trunk. The car to the right has a trunk. So clearly, you know I'm not lying. Now, corresponding means that even though I have two different cars, the trunk is located in the same space of both cars. So typically when you think about a trunk, it's located in the back of the vehicle. That's what corresponding means. Corresponding means that, yeah, I might be looking at two different objects, but the thing that I'm focused on is located in the same spot of the two different objects, okay? Let's take another example. Let's look at both of these houses, right? One house is a little small, one house is really huge, right? And hopefully if you guys do what you're supposed to do, you're gonna be living in one of these huge houses, man. You know, give me a call one day and I get a chance to take the tour of your nice, huge house. Psych, that would be weird. Very inappropriate and weird. Disregard that. Hey man, cut that out the tape. All right, so looking at both houses, right? Small house, large house, two different houses, but both houses have what we call a roof, right? And so the bigger house has a roof, the smaller house has a roof. Even though we're looking at two different houses, each house has a roof at the top of the building. So the roof for both houses would be considered corresponding because it's in the same location of two different shapes. It's in the same location of two different shapes. All right, cool. So hopefully you guys get an idea of what it means for something to be corresponding. So when I jump into this lesson, which we're going to do in a few seconds, when I jump into this lesson, I want you guys to keep that in mind, that when we look at proportions, we're taking two different parts and we're comparing them to each other. But the key thing is both parts have to be corresponding. Okay, so enough of this yip yap. Let's do what we came here to do. Let's jump into this thing. Here we go. Okay, so we're gonna look at the very first example. In this example, I have two triangles. Each triangle has some values, and the first thing I wanna do is find the corresponding parts. Remember that proportions can be represented as ratios, which is simply like something along the lines of a fraction. Okay, so let's look at the first part. I'm gonna identify a number. I'm gonna identify the number 20. And I see that 20 sits on the top side of the first triangle. So now I want to find the corresponding part on the following triangle. And I see that that's 4. So we're going to take the corresponding parts and create a ratio out of the corresponding parts, where the first value is going to be 20. And I'm going to place that over the second value, which is 4. Then I'm going to set an equal sign or create an equal sign. And then we're going to set it equal to the next set of corresponding values. So at the bottom, or the base of this triangle, I see a 35. And at the base of the other triangle, I don't have a value. So this is going to be known as the unknown. So we're going to have to use this value or this unknown value and represent it as a variable. So now I'm going to create my ratio with those two values. So the first thing I'm going to do is place my 35 at the top. And underneath that, since I have an unknown, I'm going to replace it with a variable. Almost home, guys. Everything is set up beautifully. So now at this point, we do something called cross multiplication, because I've gotten all of my corresponding parts set. My 20 over 4 equals 35 over x. So now we're going to cross multiply. So from this 20, I'm going to go across and multiply that to this x. And I know that 20 times x is going to equal 20x. Okay? And I can't forget that there was an equal sign there, but before I do that, let's cross multiply the other side. I have 4 times 35. So I'm going to place my equal sign, and I know that 4 times 35 should give me 140. Okay, so guess what we have now? A linear equation that we can solve. So we're going to solve the linear equation. Remember, that was the first thing that we needed to be able to do in that standard. So in order for me to solve this linear equation, I got to get rid of the number that is connected to x. In this case, it is 20. So I'm going to divide by 20 because the number connected to x was multiplied. Okay, so divide by 20 on both sides. When that happens, I know that 20 divided by 20 is going to give me 1, or it's going to cancel out. And then I know that I have 140 divided by 20, which is going to ultimately give me 7. So x equals 7. I've solved for the linear equation. All right, so let's, easy peasy. Let's move on to the next example. So in these two examples, I have two triangles. And again, the first thing I want to do is find the corresponding parts first. Remember that. Find the corresponding parts first. Okay, so now I'm going to look at side AB, which is equivalent to 10. And I know that the corresponding part to side AB on the other triangle would have to be side DE. But we have a problem there. We have an unknown. I don't know what the value is there, but that's okay because we can take the unknown value and represent it as a variable. Remember, that was the third thing that was required for us to master this standard. So I'm going to put 10 over x, and then I'm going to place my equal sign, and then we're going to do the same thing with the following corresponding side. So now I'm going to look at BC. And when I look at BC, I see the value 16. And then the corresponding side to that is going to be EF, which is 12. So we're going to take 16 and place it over 12. Remember that corresponding part is very important to this lesson. If you understand that definition, this is fairly simple. So now that I have my proportions set up, I am going to, you guessed it, cross multiply. I know that 10 times 12 is going to give me 120. I'm going to place my equal sign, and then I'm going to cross multiply on the other side, which is going to give me 16 times x, which is merely 16x. So now, once again, I have my linear equation. Okay, so in order for me to solve this linear equation, I got to get rid of the number that is connected to x. In this case, it is 16, so I'm dividing both sides by 16. And when I do that, I find that 16 divided by 16 is going to cancel out. And then I know that 16 goes into 20. It's going to give me a decimal. I'm looking at 7.5. So x is going to equal 7.5. For those of you all that may not have caught it, simply use your calculator. 120 divided by 16 is 7.5. All right. And so that's how I would approach that. Again, very simple, as long as we remember to create our proportions using corresponding values. Now, I love this last example because it's a real life application example where we have the sun rays that strike the building and the girl at the same angle, forming the two similar triangles shown. How tall is the building? Okay, so I'm looking at the first example. I see that I got two triangles. I'm gonna look at the base. The base of this example is 3 for the young lady. And then when I look at the base for the building, I see that it's 15. Those two values are corresponding. That means 3 represents the bottom or the base of the first triangle, and 15 represents the base of the second triangle. So remember, corresponding part over corresponding part. Set my equal sign, and then I'm going to do the same thing. The girl's height is 5 feet. So I'm going to go ahead and place 5 feet as my first value for the proportion. And when I take a look at the building, I notice that a height isn't given. Duh, that's what they're asking us to solve for. So I'm going to just, again, know that this is an unknown, and I'm going to represent the unknown using a variable. If you can tell by now, there's really only one letter that I like to roll with when it comes to unknowns, and that's the letter or the variable x. You can use any variable you want to, but that's just the one that I've learned to love over the years. All right, so now we got our proportions, and so now we're going to cross multiply. I know that 3 times x is going to give me 3x. Set my equal sign, and then cross multiply this 5 and 15. 5 and 15 is going to end up giving me, what is that? 75. Okay, and now I'm just going to solve this linear equation. And I'm going to do that by getting rid of the number connected to x. In this case, it's 3. So I'm going to divide by 3 on both sides of my equal sign. After doing that, I know that 3 divided by 3 will cancel itself out. And I know that 3 goes into 75 25 times. So x is going to ultimately equal 25, which means that this building has a height of 25 feet. And that's how we do it, guys. Oh, let me get my spelling together. There we go. All right, that's how we do it, guys. All right. All right, guys, I know that was a lot to take in. So hopefully you get a chance to do some more practice. Obviously, practice makes perfect. So keep working on it. Okay. If you happen to have any more questions or concerns about this lesson, do me a favor. Drop me a comment. I'm not one of those guys that disregards all the comments that they get in the video. I will respond as best as I can to hopefully give you a little more clarity. All right, guys? But either way, that's all I got. Thank you for taking the time out. I appreciate it. Have a wonderful day. It's been real. Deuces.